In theorem 1017, when one of the chords is Jm and the other chord, instead of being a chord, is going to be a tangent, then the theorem says that this tangent Jk squared is going to be the product of the whole segment Jm times the exterior part Jl. This is what my theorem says. Well, let's see an example. Use the intersection of a secant and a tangent. Given that PQ is a tangent of the circle, find x. X is going to be this little piece here, and PQ is a tangent from this circle. All right, let's use the theorem then. By the theorem we just saw, 1017, this tangent PQ squared is going to be the product of the large secant SQ times the exterior part RQ, is what it says the theorem. Let's substitute. PQ is 8, so it's going to be 8 squared. And the product of the whole segment SQ, that is 7 plus x, here 7 plus x or plus 7, times the exterior segment RQ, that is x. Once we apply the distributive property, x times x plus x times 7, we have this equation here. We subtract 64 from both sides and I have this quadratic equation in x, meaning it's a polynomial, x second degree, x first degree, and we have to solve it by the quadratic formula. This is a quadratic formula, and we know that a, b, c are going to be the coefficients of this equation. A is going to be the coefficient of x squared. In my case, it's going to be 1. B is going to be 7, the coefficient of x, and c is going to be my constant. It's going to be negative 64. So substituting in this quadratic formula, I have this equation. I do the numbers inside the square root, and I have a square root of 305. So I'm going to have negative 7 plus minus the square root of 305 divided by 2. Simplify, and I'm going to have approximately 5.2 and negative 12.2 as the answer for x.